Assalamualaikum. Very good morning to all. Okay, looks like some table here. Who sit here? Only their notes over there. Okay, so yesterday we stopped here, right? Okay, we did a proving on this one, and then we prove it that for signal, okay, a n u n, okay, a n u n. If you have a n u n, you can actually write the Z transform as Z over. So basically, this one, either you write it in this term, or you can write it in 1 over 1 minus A inverse minus 1. Same thing. How you convert this? Okay. So basically, from this Z over Z minus A. So if you see in the table for Z transform, in the Ulearn, I gave you two types of table. One is this one, another one is this one. So either one is the same thing. Okay, so how this from this format change to this one is that by dividing Z over Z. So what you get is, okay, 1 over 1 minus A over Z. So whereby is in this equation. So basically 1 over 1 minus A inverse 1. Okay, and for you, and yesterday we have actually derived it, and for the UN, A and UN, what type of signal it is? It's a left-sided ke right-sided? Right-sided or left-sided? Right-sided sequence, right-sided sequence. Why? Because you have UN. So right-sided sequence means that you have 0 here, okay? Then all the value on the negative side, okay, it's 0, and then you have positive until infinity. So basically for right-sided sequence, the equation for Z transform is given by this one. 1 over 1 minus A minus A inverse Z. And the ROC is given by Z more than A. Okay. And then we didn't do this derivation, but you can actually refer to my YouTube. So basically, similarly, since you can identify that this one is UN, so it's basically a right-sided sequence. So the equation that you use is still the same. So you use the Z transform, is Z over Z minus A, or 1 over 1 minus A inverse Z. Okay, and the ROC is Z more than A. Alright. Then example 3 is, I didn't do derivation, just that I'm going to just explain the difference between the right-sided and left-sided. So yesterday also we have gone through it. So example 3, okay, if you look at the equation, is it a left-sided or right-sided sequence? Right-sided or left-sided? Is it 1 m minus 1? Okay, so basically we are just looking at this equation, this one. Okay, so you have u minus n minus 1, right? So if you look at that equation, okay, so this one, the one that I highlight. So if you look at this, chapter 1, what can you identify it? what type of basic signal? Unit step, ramp, or delta? Ayan? Why? Because U, because it's a U. It's not a delta, it's not a T. Sorry, it's not a it's not without a U lah. So basically, if you look at it and then you see that there's a U, then directly you know there's a step signal. And whatever in the bracket over here, so step signal, the symbol for step, basic step is U N. Okay, so what happened inside here is all transformation. Okay, transformation that you have learned, time shifting, time reversal, time scaling, whatever that you have learned. Okay, so based on this, you try to do the plotting, then you will get it in terms of left-sided. So left-sided sequence. So for this type, if you look at it directly, if u minus n minus 1 is left-sided, so left-sided sequence, then the equation for z transform is given by this one. Still the same like the right-sided sequence. The difference is what? The ROC, right? The ROC, okay, is less than A. Right-sided sequence is ROC is more than A. Okay. So we go to this example. Okay, let's consider a single that is the summation of okay, let's consider a signal that is the summation of real exponential. So you are given xn. Okay, so for z transform, you're not going to be given xt lah. Okay, because in z transform is all in discrete time. Okay, so impulses. So it's given in the equation of xn. Xn is given by 7 1 over 3 n un minus 6 1 over n un. So let's look at this example. We do it together. Okay, if you have gone through my video, you already know the answer. Okay, because in the video also have the answer. Okay, and inside the slide also have answer. But can you actually derive it on your own? That's the question. Okay, so okay, let's go through. Okay, so first step. Okay, A, okay, given x and find z transform. So basically x, z. Okay, so what you need to do first step is write again the equation. Okay, so x and this size, is it okay at the back? Boleh nampak tak? Acap? Can see? Okay, kalau if you cannot see, then come to the front. That's all. Okay, xn equal to 7 1 over 3. Okay, to power of n un minus 6 1 over 2. 1 over 2 and u n. Okay, so how you write this is, okay, the solution. Okay, we are going to rewrite this in terms of how many signal that you can find. Okay, so you can identify that you have the first signal, whereby this signal. Okay, and basically what you need to do is that you are going to apply the Z transform table lah. So open Z transform table. Okay, so this is appendix. So in final exam, you will get this appendix, the whole thing. Okay, so be familiar with the appendix. Z transform. This one, and also you are given the other appendix, which is the one that familiar to you, okay, this one. So this one is what I have used in the previous yesterday class, So based on this, what you need to do is that you are going to actually inspect the signal Z transform here. Okay, by inspection. Okay, by inspection, let's just take this signal. Okay, I'm going to take this to signal. Okay, by inspection, determine determine, okay, the Z transform lah. Okay, the Z transform. Okay, so you have here basically the xn value. This is xz. Okay, this is ROC. Okay, so how we go by to answer this is that we are going to write xn in terms of xz. So how we do it is that we are going to actually use Fourier Z transform. Okay, so by inspection with this table that you know lah. Okay, so we are going to write xz by inspection of this. Okay, the first signal. Okay, we can say that this is the first signal. Why? Because you have an. If you write it again, this is actually a to the power of n u n, right? Okay, with a value lah. So you have 7 here, the amplitude. Okay, and then you have another signal minus 6 a n u n. Okay, so by inspection, a n u n is which formula? 2 or 3? Oh sorry, where's the ANUN sorry, I took the wrong equation sorry, patutlah blur je. No wonder blur. Yeah, sorry about that. This one okay, so this is xn, this is ROC. Okay, so by inspection, ANUN represent which one? 5 or 6? 5. Very good, it's a 5. So basically we can write it first. Try to write this xn into the equation lah. So you write it as x1, sorry, xn equal to x1n plus x2n. Sorry, tulisan I sekejap you jangan padam, tulisan I je ni. Plus x2n. Okay, so when you compare, you can actually write this because you want to convert it into Z transform. So xz. Okay, so xz, by comparing, you can write it as what? 7. Okay, directly use the exact value. So you have 1 over 1 minus, what is the a value? 1 over 3 1 over 3 inverse z. first equation. Okay, and basically this is wrong lah, because why? This is minus, right? Okay, so this one is x1 minus x2, right? So next is that you have the second equation, which is minus 6 in bracket, what is a value? 1 over 2, eh? So 1 over 1 minus 1 over 2 inverse z. Can understand this one? If you cannot understand, then you need to do one by one lah. So basically, if you were to write it one by one, then you write it first. Okay. If you cannot do this directly, you can write it as x1 n, okay, equivalent to apa equation 7, 1 over 3 power of n un. So the z transform is x1 z, you get 7 1 over 1 minus 1 over 3 inverse z. First equation. Second equation, x2n. Okay, do one by one. Okay, so second equation is that 6 1 over 2 n un. So the z transform is x2z. We are doing it one by one, because in exam it's not going to be two signal only. It's going to be multiple signal. So if you do by one, you won't make mistake lah. At least out of the 4 signals, 3 correct, 1 is wrong. Okay, so x2z equal to what? 6 1 over 1 minus 1 over 2 inverse z. Okay, then only you combine it. Therefore, okay, xz equal to x1z, okay, minus lah, okay, minus x2z. Okay, so when you write this x2z, then you will get this equation again lah. So let's just write that out. Okay, 7 over 1 minus 1 over 3 inverse z minus 6 over 1 minus 1 over 2 inverse z. Okay, this one 1 over 3. So what was the question? The question is that find the z transform, right? So how do you find the z transform? Okay, so basically we cannot leave it like this. Okay, what we need to do is that we need to make it into one denominator. Okay, so 1 minus 1 over 3. Reason why they aim for in chapter 5 z transform is to find stability. So you want to plot ROC, and ROC is the numerator will need to be in one equation. It cannot be in this term. Okay, so 1 over 3 inverse z, 1 minus 1 over 2 inverse z. So how are you going to do this? So you're going to cross multiply, right? Cross multiply, cross multiply. Okay, so you have if it gets confusing, I don't like to do cross multiply like this with the z inverse. So let's just convert it first. Okay, let's just write it first at this side. Okay, I'm going to multiply both sides here with z over z. Okay, and both sides also z over z. So we rewrite it again so that it's easy for you to multiply. So what do you get? 7z over z minus 1 over 3, okay, minus 6z over z minus 1 over 2. Okay, then only cross multiply. So I'm going to rewrite this. So cross multiply z minus 1 over 3, z minus 1 over 2. Okay, we have 7z multiplied by z minus 1 over 2 minus 6z z minus 1 over 3. So try to multiply it. What do you get? What do you get for the numerator? So the numerator you can write directly. So it's z minus 1 over 3 multiplied by z minus 1 over 2. Okay, the numerator, multiply it. Expand. This one. 7z multiplied by z minus 7z multiplied by 1 over 2 minus 6z squared plus, okay, expand it. So what do you get? Let's check with my answer. Just use your brain. Okay, anyone finish? Besok kan? Pukul berapa? 9 kan? So, Bangladesh boleh datang pukul 9. Ya. Okay, jom, let's expand. So, you have 7z squared, okay, minus 7 over 2 z, okay, minus 6z squared plus 6 divided by 3, 2 z, right? Okay, expand it. So 7z squared minus 6z, so you get z squared. Okay, 7 over 2 plus 2z. How do you do that? Congak tepi lah 7 over 2 minus plus 2 over 2, 2. So 4 over 2, right? So you get minus 3 over 2. No calculator needed. Okay, so you get minus 3 over 2 z. Then z minus 1 over 3 over z minus 1 over 2. Okay? Okay? Do you know how minus 7 over 2 become plus 2z become like this? This one. Minus 7 over 2z, right? Plus, okay, minus 7 over 2z plus 2z, right? Okay, so I expand it, become like this. Minus 7 over 2, same thing. Plus 2, you want to make the numerator the same. So 2 times 2, 4 over 2. 4 divided by 2 is what? 2. So that's why you get 4 over 2z. So minus 7 over 2 plus 4 over 2, then you get minus 3 over 2 lah. Oh, can press calculator. Okay. I would suggest in final exam, do not, if you press calculator, you get 0.5, 0.4 is okay. But sometimes in the equation, you get like 0.3333 and so on. So basically, it's better to leave it in terms of 1 over something lah, in terms of the equation. Okay, so x z. However, based on what you have learned in the Z transform table, we are referring to this table, right? So you want to leave it in 1 over 1 minus A inverse Z. So what we need to do is that divide this by Z over Z again. Because just now we convert it, right? So divide it again. So that it's in the familiar form lah. So you divide it by Z over Z, then you get Z minus 3 over 2 over 1 minus 1 over 3 inverse Z. Okay. And then 1 minus 1 over 2 inverse Z. Okay. So this is the answer. Okay. So the question, if you look at the question, we answer question A. So the second question that sketch the region of convergence for Xn. So basically, in order for you to sketch for Xn, you need to convert it first to Z transform, right? So this is what you did lah, exact. So now after you get the exact, then they ask you to sketch the region of convergence and also find if the system is stable or not. Okay, so basically from here, B, the sketch ROC. Okay, go up. So what we are going to refer is only the, which part? Numerator or denominator? Denominator only, which is this part only. Kenapa jadi lain? Oh, highlighter. Denominator, only the numerator. Okay. So, we only have how many ROC here? We have number 1. Okay. And number 2. So, we can write it as, therefore, the ROC. Okay. Take out the first one. Okay, 1 minus 1 over 3 inverse 1 z inverse 1. Okay, and then I'm going to write both first. Okay, 1 minus 1 over 2 inverse 1. Okay, we are going to find what is the ROC. Okay, so based on this, how do we determine that whether or not the ROC is z less than a or z more than a? You are going to refer back to the yn, right? The equation, original equation. Original equation, if you look at the original equation, we have determined that we are using the right sequence. So z is more than a. Okay, so you're going to write directly, therefore z is more than a. Your a value is what? In the first equation, more than 1 over 3. Okay, that one is first one. Okay. So it's important for you to know which equation to use, because if you choose the wrong equation, you choose the left side equation, then your ROC would be wrong, which is z more than a. Okay. Second, so what is the ROC directly? It's more than a, right? So you get more than 1 over 2. Okay. Since the question asks you to sketch, so you need to sketch the ROC lah. So sketch ROC, draw the plane first. Okay, imaginary, real value, z plane. Draw 1, unit circle, minus 1, 1. Okay. Unit circle. Okay, boleh lah. Okay, tak boleh. Okay, unit circle dia ada offset sikit I draw it at that line but it offset a bit. Okay, and then you're going to write out where you have for 1 over 3. So 1 over 3 and 1 over 2 is where? 1 over 2 is half, right? 1 over 2 minus 1 over 2. 1 over 3? Here, right? Over here, right? So you have 1 over 3. Mana pula? That is 1 over 4, right? So testing only, 1 over 3 minus 1 over 3. Okay, so let's draw the first one. The first ROC is z more than 1 over 3. So you imagine that you're going to draw 1 over 3 here, circle. Okay. And then where is the 1 over 2? So draw also 1 over 2. 1 over 2. If you imagine that both are what type of ROC? Outward or inward or ring shape? This one is outward, outward. This one also outward because z more than a, Okay, so imagine that all is outward, going out. So which, since you have two ROC value, the first one and second one, so you need to find which of the two overlapping. Okay, so if 1 over 3 is only overlapping at 1 over 2, right? So when you draw is this, basically you draw like this. Okay, means that first one is 1 over 3. However, if you draw 1 over 3, 1 over 2 is not overlapping. Dia kena 2 ROC overlapping. So therefore, okay, we are not finished yet. Therefore, the ROC for HZ is Z more than 1 over 2. Okay. And the system is stable. Okay. So this one, okay, why in the end you need to make a statement? The statement is that for the system, it's because you have multiple ROC in the equation denominator. So you need to make a statement in the end that the ROC for HZ is Z more than 1 over 3. Why? Because you need two value of ROC overlapping. You cannot pick it Z more than 1 over 3. Okay? Because this part here is not overlapping. Okay? Not overlapping with 1 over 2. Outward, right? Okay, so we are picking only the one that is blue color lah. Blue color over here. Okay? And because it cover unit circle, okay, so so your statement you can say that the same is stable because include unit circle. Include unit circle. Okay, that will be the statement. So it means that stable Y, not stable Y. Okay, anyone have question? Nampak tak faham nak lorek. You want me to write here or here? Here. I hate it. Okay, so I try to write on the right side. Okay, right side. Again. Okay. Because there's question. Okay, how to actually sketch it? Okay, so based on the denominator, you come up with two ROC. Example, if you have another denominator over here, the equation factor, then you have 3 ROC. For now, you have only 2. Okay, so you 2 for each of these, you need to determine what is ROC according to the equation. Okay, that one understood at the back there? Okay, so understood. However, the question say that, okay, sketch ROC is one thing, but the question asks you, is it stable or not? Okay, stable or not, it need to, the ROC for both value here, number 1 and number 2, need to be including unit circle. Need to be, not only one value. Okay, so for this case is that, if I draw, okay, unit circle is 1 here. Minus 1, 1. Okay. So imaginary, real. Okay. Okay, we plot the first one lah. ROC 1/3. 1/3 is where? This is 1/2. 1/3 is here. So 1/3. 1/3. Now let's plot the first one. Plot. I'm plotting using a different color. Okay. So Z more than 1/3, you plot it towards, okay, outward. Outward. It's like coloring class. Okay. So Z more than 1/3. Okay, that one is the first sketching. Secondly is that you have another one is Z more than 1/2. So Z more than 1/2 is where? Is this one, 1/2 is minus of 1/2. 1/2. Okay. So basically from here, you are going to sketch also Z more than 1/2. So Z more than 1/2, I'm going to sketch using the blue highlighter. So 1/2 is here. Alright. Done. That's only sketching. But the question asks, is it stable or not? By definition, what was the stability for Z transform? Your ROC, if you have two ROC, then both ROC need to include unit circle. Both. So for this one, it's already include unit circle. But when you do the sketching, which sketching that have both overlapping unit circle? At Z 1/3 or Z 1/2? Both sketching, the one that I sketched in blue and yellow. Which one that have both? 1/2. 1/2, right? 1/3 only have yellow there. Okay, so you need to take the one that have both overlapping. So therefore, ROC need to have both ROC overlapping. Means that the sketching overlapping both. For this case is that, okay, this inner part only yellow. Okay, it's not done yet because it's outward. Okay, this one only yellow inside. 1/2, we have both yellow and blue. So by definition, ROC is defined when you have both, including sketching it, including the unit circle. Of course, both including unit circle, but we need to know what at what Z value. What Z value that include both? At Z equal to more than 1/2. You get it? Okay, so okay, that's where you come with the statement below lah. This statement. So therefore, the ROC for the system haystack is Z more than 1/2. Okay, if you answer 1/3, then wrong lah. Okay, because you need two of the sketching to overlap. Okay, and the system is stable because of it include unit circle. Okay, let's do just one simple sketching and let's see if you can answer it. Okay, let's say that just remove this. Okay, I'm going to use the same drawing also. Okay, let's say you have when you do the derivation, okay, you find one of the ROC is Z more than 1/3. Another one is This is number 1. Number 2 is Z less than 1/2. Try to plot it. So find the ROC for his Z, for this, if given the ROC here, these two. And is it stable? Okay, so try to sketch Z more than 1/3 means that outward. Z less than 1/2 is inward. Find the two sketching that is overlap. Okay. So what is the ROC? When you combine this ROC, you sketch, you get donut shape, right? In the middle. So ROC is what? Z more than 1/3, less than 1/2. Write it in one statement. Is the system stable or not? Stable. What's the definition of stability for Z transform? Must include the unit circle. Does it include the unit circle? Inside the one? No. It must include. Okay, we will do an example that it include the unit circle. Okay. So basically, so everybody get it. Sketching. So let's try to do it together. Okay. Okay. Before that, okay, based on the ROC, can you determine what type of signal you have? Is it left-sided or right-sided? For Z more than 1/3, is this left-sided or right-sided? Right-sided, right? Just now we do the exercises, So basically this one is for right-sided sequence, UN. Okay, AN, UN. Okay, so basically you get the right-sided sequence. Another one is that Z less than A. Z less than A, if you look at the table, okay, Z, the same equation, Z less than A is left-sided sequence. Okay, so basically if you convert it back to YN, you get a left-sided sequence equation. So this is a left-sided sequence. Okay, so let's plot it. First, we plot the first Z more than 1/3. So Z more than 1/3 will be outward. Outward. Okay. Second one is that, this is first one. Second is Z less than 1/2. Z less than 1/2 means that inward. Inward, ROC is inward type. So inward type is this one. So in order for you to determine the ROC is that you need to have both of the sketching overlap. So from here, what do you get? Therefore, ROC is Z more than what? 1 over 3 less than 1 over 2. So this is how you write the ROC. And basically, from here, you might notice that, oh, donut shape, basically you get a donut shape when you have one is in a right-sided sequence and one in a left-sided sequence. Okay, one will be outward, one be inward. And when both overlap, you get a donut shape or ring type. Okay, so this easy. So if you have both in left-sided, you only have inward only. Okay, if you have right-sided, then both are all outward, but you still need to determine what is the ROC. So from here, okay, if I were to draw it, okay, ROC, because I'm using already multiple color here. So the one that I color purple, okay, is basically the ROC here. Okay, so does it include unit circle? Where is your unit circle? It's outside here, Does it include? No. So when it does not include, then the system, therefore, the system is unstable because it does not include unit circle. Okay. So how do you actually manipulate the Z here? How do you want to include the unit circle? You need to have Z less than 1 over 2. Okay. Basically, Z here, the second equation, you should have Z less than A value, right? So if you want to include the unit circle, then maybe A value is 2. Okay, so if A value is 2 is where? Here, right? So if you draw it, does it include unit circle? Yes. Okay, so if you want it to include unit circle, then the A value for the left hand side need to be larger than 1 lah, basically. Alright, so this one, okay, we take a break, already like 12:15. We take a break. Okay, inverse Z transform property, normally we will combine it together. Even for today, for the system model, I'm going to start to introduce you to the Z transform properties. Okay, so look at this slide. So basically, if you look at this slide, okay, okay, it says here that most of discrete time system are described as differential equations. So just now in the exercise, so basically we written it as differential discrete time domain, and we write it as a differential equation yn. Okay, un. Okay, it's actually a differential equation. Okay, just that if you have it in terms of shifting everything, then it becomes a total differential equation. Okay, and this differential equation, if you write it into the given equation here, so we can write it as a summation of ak yn minus k. So basically, you know that this is property of shifting value. Okay, yn minus k means that yn minus 1, yn minus 2, yn minus 3, and so on. Okay, this is on the y factor, and it will be equivalent to summation of bk. So basically, what it says here is that most of the time, you're going to find what is hz, okay, or let me just write it as hn, so because this is in differential equation, so hn, and hn most of the time are yn over x So if you write it out, you can write it out as summation of y value equal to x value. Okay. And when you write it in terms of Z transform, then basically you are going to convert the discrete time domain into the Z transform using the Z transform. So this one is, we are looking at the shifting property. So if you look at here, a, y, n minus k. So shifting property is given by this table, this one. Okay, time shifting property. So you have x, n minus n naught. N naught is the shifting, 1, 2, 3, 4. It can be positive, it can be negative. Okay, and how you write the Z transform is that, okay, xn, you know, is a signal, xn. N naught is the shifting property. So what you need to determine is that what is n naught. Okay, so if n naught is 1, so basically you write the equation as, okay, x n minus 1, right? Okay, so this is shifting property that you have learned in chapter 1, time shifting. Okay, so, and if you want to convert it into Z transform, then you write it directly using a table of Z transform. So you write it as Z minus, what is n naught? 1. Because n naught here is equal to 1. Okay, minus 1 exact. So that one is the representative of xn minus 1 in terms of Z domain. Okay, so we have the time shifting. So based on this, we are going to apply it to system models, understanding of that. So we go to the system model. So basically, if you look at this slide, this slide shows to you the equation in time domain, which is yn equal to 2xn minus blah 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 and so on. And you can convert it into Z domain. So basically, we use the Z transform table, directly convert it. Okay, and from both of these, you can also draw out the block diagram. Okay, so for today, I'm going to give you the example. Okay, but before that, we go to what type of system connection that you have. So this one also we have covered in chapter 1. So I'm going to be very fast. So you have the cascade type, which is basically you have H1, H2. So you get it, then you get H1Z times Hz. Okay, first one. Parallel means that, this one, basically, cascade and parallel is what being asked in midterm. Question 2, remember? Find Hn when you have this type of block. So basically, you need to add H1 plus H2 lah, that time. And B question is that find in terms of cascade. So you do the convolution sum, supposedly. Okay. So parallel is just a simple adding the Hz plus H1Z plus H2. And this one you will get the impulse response signal, Hz. Last one is the feedback, which is you have seen this a lot of time in what subject? Control subject. Okay, control subject Y is a feedback because you have the positive here, and the feedback from the Y is being feedback negative feedback. Of course, sometimes there will be positive feedback, but when you have a negative feedback, this is how you write the equation, and I believe you already know how to derive it and get this equation. Okay, so let's do example 1. But before going to example 1, let's do look at this one. I'm going to explain one by one what are the components that you need to draw into the system modeling in terms of time domain and Z transform, Z domain. Okay, so write this. Okay, this one is not in your slide. I just come up with it today because easier to explain first one by one, and then only we build up the block diagram. So system model, this is system models, which is definition is that a linear constant coefficient for a different equation can be represented by a block diagram. So basically it means that if you are given yn, xn, you can actually draw it into a block diagram. If you are given in terms of Z domain, you can also draw it into a block diagram. Okay, so there are 3 elements. Dah finish. I wait until you finish writing. Finish? Okay, so the first element, okay, there are 3 elements under this. In order for you to understand how to draw the block diagram. So 3 elements. The first one will be scaling. Okay, so let's say that you have xn as the input. The scaling factor will be written as a value, and you have output yn. Okay, this is normal. A means that what? Scaling factor means that it's 1, 2, 3, and so on lah. It can be 1/2, 0.5. So it's just a value. Okay, so if you write this in terms of equation, you get what? Yn is equal to a x n. Okay, so in this term, I'm going to share also how you write it in terms of Z domain block diagram. So you have xn. So the Z transformation, you write it as x z, right? A is still a. Okay, y become y z. So the equation become yz equal to a x z. Okay, first element. Second element will be the adder, or we call a summation point lah, basically. So we have a summation point. Okay, plus this one x1n, x2n. Okay, yn. Okay, so how do you write this equation? So yn equal to x1n plus x2n. Okay, let's write the Z transform. Okay, convert it into Z transform. So you can write it as x1 what? Z. x2 become x2z. Y become y z. Okay, write it. So yz is x1z plus x2z. Okay, can follow Okay, basic first because later we do a complicated block. This is basic. If you cannot understand this, then convoluted box will be impossible for you. So last one is delay block. Okay, delay block. Delay block, basically, if you look at what we have defined just now, delay block is basically the shifting, right? Time shifting. Okay, so original signal is xn. If delay block become x n minus something, right? N minus 1. Okay, so to draw a delay block, you draw it as in terms of delay. This is in time domain. Okay, so input to this is xn. Output is yn. So means that D means that delay by 1, value 1. Okay, so how do you write the equation yn? Yn is x n minus 1. Okay, so D represent delay by 1. If you want to make it n minus 2, then you need to put there 2 delay blocks. Okay. Okay, so let me just let's do the Z transform. So for Z transform, the delay blocks, you need to convert it into a different block. You cannot use it as delay. Okay, we draw it Z minus 1. Why? Okay, based on the property just now, property of Z transform. What's the property? Okay. Tak ada. Okay, ni Ayah. Okay, this one, the slide, my slide. This one, this property, this one, time shifting. Okay, so based on this property, when you have x n minus 1, how do you write it? Z inverse 1, right? Okay, so the delay part, you are going to write it as Z inverse 1. Okay, so the block become x z y z. So yz is represented as z minus 1 x z. So this is basically what you did when you refer to the Z transform table. Alright? Done Okay, now we do example 1. So example 1, okay. Before that, can you do correction? There's a correction in the slide. Okay, example 1, no correction. Example 2, we are going to learn how to, if you are given the time domain block, draw it in Z domain. Z domain. Okay, the one that I highlight yellow is the correction. In your slide is time domain. This one is Z domain. Example 3, correction also. Okay. The correction is that in your slide, example 3, you have the like this, right? Okay. Y is here. Okay, correction is that this one feedback here loop, and then this one connected. This is YZ. Okay, correction. Okay. So example 2 and 3 only correction. Okay. So let's look at example 1. So for example 1, the question is that find the transfer function for the time domain. Okay. So basically time domain means that what? You want to find the transfer function in terms of h n, okay, equivalent to means that we need to find in terms of summation of yn equivalent to summation of y xn, summation of n minus n naught equivalent to summation of x n minus n naught. Okay, we want to find in this term. Alright, so similarly like how you learn control. So what we do first is that we are going to write out what is the point over here, each of the point. So let's say that I'm going to write it as this one yn is yn. Okay, this point is yn. Okay, what else that you can write? Okay, we use only yn only. So now we start to write out the equation. Okay, I'm going to write it directly in the block. Okay, so you have here yn delay. So how do you write this equation? Y n minus 1. Why? The 1 delay block means that delay by 1. Okay, 1 delay block is delay by 1. And then I can write also underneath here, another point here. If you look at here is yn. Okay, Okay, you have 2 delay block. So what do you write here? Yn minus 2. Oh, very good. Okay, now we try to build it at this point. This point. Okay, so this point, what the equation that you have? You have basically a 0.6, which is a gain. So you can have the option whereby if you draw a block, you can draw it like that. This also is okay. Okay, means that the block, because just now when I teach the basic one, you have the scaling factor, right, as the gain. Okay, so you can write it as 0.6. Okay, also for this one, you can write it as 0.8 gain value. Some books, they don't put it the gain in a block. Some books, they just put arrow and they put the value of the gain over there. Okay, so over here you have both plus and plus. Okay, what you see over here is that you have plus and minus. So my advice is that if you see there's a minus there, try to take out what is the gain value. So we want to change this become plus. Easy for you. So this become minus 1. Right? Okay. So that later when you draw, when you are given, for example, right now we are trying to find transfer function. Later, you are given transfer function, draw the block diagram. So my suggestion is that when you draw the summing point, draw it positive both. Gain, you have negative, then put it negative. Okay. So now we continue at this point. This point, what do you have? 0.8 y and minus 2. At this point, 0.6 y and minus 1. Okay. Here, okay, so this point times this one, summation point, and then you have gain minus. So we write it directly. So you have minus 0.6 y and minus 1 plus 0.8 y and minus 2. Okay. Now we can build the, basically we want to build y equal to x, right? Okay. So let's write it out. Yn here equivalent to what? Xn. Xn is this one. So we are looking at yn, xn, and only this point. Why? Because we already do the summation, right? Just now, the multiplication of the gain value and so on. So we only look at this 3 point, yn, this xn, and also this point over here. Okay, so yn, okay, is equivalent to xn plus, but you have here minus, right? So directly minus, okay, 0.6 y and minus 1, because minus, and so minus 0.8 y and minus 2. Okay, all right. So this will be can you leave it like this? I would suggest that leave it in xn on the left side, yn on right side. So organize it again. So you have yn over here. Okay. So let's say that xn, I take it to the left side. Or you want to stay it. So we just follow what we have here. So yn. All of this term, we are going to bring it to the left side. This one. Okay. Bring it to the left side. Okay. So you have here plus 0.6 y and minus 1. Okay. Plus 0.8 y and minus 2. Okay. Equivalent to xn. Okay. So this is the answer. They ask you to find We have not finished yet because the question is, of course, the question is that us in time domain, but we are in Z transform. Z transform. That's the reason why I asked you to organize it this way. So let's say that we have an update on the question. After that, question B is that find the Z transform. Okay. So basically, you are going to use this equation. Using Z transform, directly compare with the Z transform table, right? And property lah. Okay, so Yn what you get? Y Z plus 0.6 Yn minus 1 is a shifting property. Okay, shifting property, how do you write it? Z inverse 1 Y Z. Shifting property, this one is all shifting property. This one, shifting property, shifting property. So let me just write here, shifting property. Also same thing here. Okay, so you need to refer to the shifting property equation. So shifting property, sorry, not equation, table, table is this one. Okay, x n minus 0, right? So your shifting is 1. So you write is sz minus 1. Okay. Okay, so then we continue. Plus 0.8. Z inverse what? Minus 2. Right? Yz equivalent to xz. So Z transform, normally we want to find it in terms of his Z, right? His Z. Okay. Because this block diagram, if you simplify it, you have learned in control. Any block diagram you want to simplify, you want to become H Z. In terms of Z transform, here's Z. This is XZ. This is YZ. Therefore, H Z is equivalent to YZ over XZ. Because just take it out. So this one basically we can rearrange it again. So I'm just writing here YZ 1 plus 0. Oh, that's not 1. 1 plus 0.6 inverse 1 plus 0.8 Z. Okay, equivalent to XZ. Now we can rearrange it. Okay, rearrange it, this whole thing, take it down, this one, swap it. So you get 1 over 1 plus 0.6 inverse 1 plus 0.8 minus 2. So this one will be the answer in Z transform. Okay. Okay. Alright, so we don't have time, but basically try to practice on your own. Okay. Let's say if you are given with this equation instead. Okay, you given in the equation that you have found here. So Yn plus 0.6 Yn minus 1 plus and so on. So can you draw the block diagram? Do you want to do it now? If not, we need to continue it. We finish now lah kot. Just a little bit only. Little bit. Only 5 minutes. 5 minutes, 5 minutes. Okay, how to draw it? Okay, draw the block diagram. Okay. Alright, so if I write again what we have gotten here. So you have Yn. Okay, Yn plus blah 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 and so on. So how you want to write it out is that we are going to take it Yn. Yn. Okay, Yn, leave Yn over here. Okay, the rest we take it to the right side. So Yn equal to Xn. minus 0.6 yn minus 1. Okay, plus just rearrange it again, 0.8 y n minus 2. Okay, you want to leave it in yn. This is the step. If you want to draw a block diagram, you're given the equation, you're going to draw the block diagram. Okay, so first step is that after you identify y is where, so we are going to draw yn at the end part. X, of course, is here lah. Okay, so so basically we can read it correctly. So yn equal to xn. Okay, and then you have plus and so on. So I'm going to write here plus here. So yn equivalent to this, the gain is 1. Okay, if you write here, can you get xn? Yn equal to xn, right? Next equation you have delay and delay. Okay, this one is one delay, this one is another delay. Okay, so how the easiest way how to write it is that draw the delays on this side, right side, near to the y output. Okay, delay, because you have two delays, n minus 1 and n minus 2, so combination of these two delay become two delay blocks lah. So D. Okay, and put another block summation over here. Okay, now we are going to write this equation. 0.6 yn minus 1. So yn minus 1 is what? Y is over here, right? Delay, go into the delay. 0.6. Okay, so we are actually plotting this. We are plotting. We just change color. This one is we are plotting this one. Okay, the blue one. The pink one is I'm plotting this one. Okay. Next we have 0.8 yn minus 2. So means that ada two delay, right? So delay block is going down lah. Okay. So you write there going down, then 0.8. Okay, 0.8. Okay, because these two are summation, so it goes into this block. Kan? This is step by step lah basically. If you already know it, then just it's a refresher. Okay, now lastly is that because this is negative, okay, x1 is where y equal to x minus the whole thing, right? So you have here the gain block minus 1. Okay, so if I color it, the green one is this one. It's basically covering D and also into this term. Okay, the minus, okay, is this one, the gain block, right? So did you get with the similar block diagram with the question? Okay, similar, Okay, so this is how you draw it out lah. So basically you are going to leave it in terms of yn here, because why? We want to, this yn is the output. Okay, xn is on the left side. Then start to do the summing point. So if you have delay, then draw it in this part. Okay, parallel. If you have only one delay, then D only one lah, n minus 1. If you have n minus 3, also additional n minus 3, so means that what? Your block diagram is going down. Okay, you have another D here, over here, okay. So if n minus 3, another delay going down. You parallel it down, okay. So based on that, we have, I believe that you can actually do the exercises in example 2, okay. Find the transfer function in Z domain. Number 3, also same thing in Z domain, but directly given in the block diagram, already converted to Z domain. So this is easy, yeah. Also this one, okay. Exercise 5, try to do at home. We will try to discuss this on Monday night. And by this week, I will upload the assignment 3. Because by now, based on what you have learned up until now, you will be able to answer assignment 3. Okay, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.